assignments, doubts, exams. We have got you back. EduPlanner make every chapter easy to understand. Stay tuned, learn more, grow with us.
So here, for part A, we're simply going to use Hooke's law in order to find the net force. We know that here we're going to use Hooke's law force being 100 newtons per meter multiplied by 0.30 meters. This is giving us 30 newtons upwards. The weight essentially is going to be 20 newtons downwards. And so we can say that the net force is giving us 10 newtons upwards. This would be our answer for part A. For part B, we can then say that the equilibrium position is where the upward Hooke's law balances the weight. So this corresponds to the string being stretched by, we can say, delta x equaling 20 newtons, which would be the weight, divided by the spring constant of 100 newtons per meter. This is giving us 0.20 meters. So relative to the equilibrium position, the block is at the bottom turning point. So essentially, the amplitude, the maximum displacement from the relative to the equilibrium position we can say that the amplitude would be 0.30 meters minus 0.20 meters. 0.30 meters would be the instant essentially at part A. So we can say that this would be equal to 0.10 meters. This would be essentially the amplitude or the maximum displacement of the spring. For part C, we're going to use equation 1513. We can say that then the period t is going to be equal to 2 pi times the square root of the mass divided by the spring constant k. This is going to be equal to 2 pi multiplied by the weight of 20 newtons divided by the acceleration due to gravity, 9.8 meters per second squared. This is to find the mass, and this would be divided by the spring constant of 100 newtons per meter. So we find that the period is equaling 0.90 seconds. The maximum kinetic energy is equal to the maximum potential energy. So here, for part D, we can say that the maximum kinetic would be equal to the maximum potential, and this would be equal to 1/2 kx sub m squared. This is equaling 1/2 times 100 newtons per meter multiplied by 0.10 meters quantity squared, and this is going to be equal to 0.50 joules. So this would be your answer for D, our answer for C. For part B, my apologies. This is the final part D. The final answer for the maximum kinetic energy, or equaling the maximum potential energy, is 0.50 joules. That is the end of the solution. Thank you for watching.